Hello, friends. I hope you all are safe. Stay home, stay safe, and I wish you all the best for during this challenging time. Okay, today we are going to discuss about the module measurement and display devices. The contents which are included in this module, these contents are actually there are two different parts of this module measurement and display devices. So, in measurement, qualities of measurement, static characteristics, errors in measurement, types of errors, statistical analysis, and in display devices, different types of display devices should be included in this part like LED, LCD, gas discharge, plasma display, segmented gas discharge display, and so on. So we'll discuss in detail about all the contents which are included in this module. Let us start with the measurement. What is that measurement? Measurement is a comparison of unknown quantity with the known standard. So this is a technique in which the properties of any object they are determined by comparing them to the standard quantity. For example, if we want to find the physical quantity of any object, like if we want to find the length of pen, so this particular pen is compared with the known standard like scale. So unknown quantity of a length of pen is compared with the known standard of scale. We are getting the correct information about that unknown quantity. So in this way, we can measure the unknown quantity by using this process. The word measurement comes from Greek word metron, which means limited proportion. That is, a proportion means comparison in between known quantity to the known standard. Now, a number of examples that we have seen in day-to-day life, or these examples are measurement of mass. So, while buying foods from the market, we should know the mass of that particular food. For example, we want to find the mass of apple. So using digital weighing machine, we can measure that quantity. So measurement of mass is necessary for purchasing such types of fruits. Second example, when we take milk from the milkman, there is also necessity to find the or measure the volume of milk. So this is very much essential thing in our day-to-day life. The third thing is while going to sew the clothes, there is a need of a measurement of length. So tailor can take the measurement and according to his measurement he will stitch the shirt. So measurement of length is also necessary in our day-to-day life. Next one is measurement of temperature. Temperature means in a fevering condition, we should know about what temperature of that person in the fevering condition. So using thermometer, we can measure that temperature. So this is necessary to find the temperature or measure the temperature in that condition. Next one is a measurement of time. Time is required in every means we can say in everything. So time, measurement of time is necessity. It require in all the fields. They can measure with the help of digital clock, analog clock, and so on. Then next thing is the measurement of speed. While going on the road with the help of this car, the speed of vehicle should know. Because suppose there is a limit of a speed on that road, we should know that what speed on which we are driving on the road. So there is a need to measure the speed of that vehicle. Then we can go safely on that road. So there is a need of measurement everywhere. So measurement is needed everywhere. Measurement require tools, and these tools provide us a quantity, and quantity describes how much of something there is or how many there are. Okay. Now, need of a measurement in physics. Measurement is one of the most fundamental concept in science. It's the most important concept. Without the ability to measure, it would be difficult for us to conduct experiment or to perform theories. For example, as we know that the experiment of Ohm's law, in which there is a equation V is equal to IR, and in this Ohm's law, voltage is directly proportional to the current passing through the conductor. So how to perform this experiment? For performing this experiment, we have to find how much value of current passing through the known value of a resistor or constant value of resistor by applying suitable voltage. So we have to measure the quantity of current passing through that resistor. So this is very important that without the ability to measure, it is very difficult to conduct this experiment and also to form the theories. This measurement is not important only in science, but it is also essential in other fields like farming, engineering, construction, manufacturing, commerce, and numerous other occupations and activities. Okay, now what are the qualities of measurement? While measure the particular physical quantity, what qualities of measurements are required so that we are using the instrumentation? So instrumentation is the field of a combination of physics and electronics. And in that instrumentation, this is a measurement technology. It works for all science as well as all the branches of engineering, medicine, and almost every human efforts. Now, the knowledge of any parameter in surrounding, because when we control any particular physical parameter, the knowledge of that parameter in the surrounding, it depends upon that measurement. So it can be easily understood by the measurement of that quantity. Now, measurement is generally used for process monitoring and also used for process control. Different measuring devices they are used to indicate the environmental condition. For example, if we find the temperature of surrounding, we are using thermometer, atmospheric pressure, barometer. So number of devices which are used for indicating the environmental condition. In air condition, as we know, in air condition, if you want to control the temperature inside the room, the different sensing devices are used to sense the actual temperature, and they are given to the controller device which are used in the air conditioner. And according to that requirement, the controller maintain the temperature inside the room. So measurement is required not only for monitoring; it is also required for process control. Different meters are also used to track the quantity of commodity used. For example, electric meter. Yeah, electric meters are used to find how much amount of electric power consumed within 1 month, and according to that reading, we are getting the electric bill. Similar to that, gas meter gives the information about how much gas which are used, and water meter is also gives the information about what quantity of water is used within that 1 month, and according to that use, they are getting the bills. The special monitoring equipments are also used in hospitals to monitor patients' condition, because patient's condition is supposed critical condition. So in every second we have to monitor the conditions of that patient. So the equipments which are used every time for monitoring the patient's condition throughout the time which are actually hospitalized in that condition. Now, whatever be the nature of application, how we can select this particular instrument? So, selection and use of measuring equipment depends upon the broad knowledge of what is available and how it is to be performed. Means the particular instrument is available, and if it is to be performed particularly for that range, then the instrument is suitable for the particular application. So it is very important thing that selection and use of measuring instrument depends upon what is available and how it is to be performed. And the second thing is some basic measurement techniques and the devices which are useful and will continue to be used. But there is always a need of improvement. Means we are not staggering only for that instrument. There is also need for the improvement and development of new equipment to solve the measurement problems. So, what is the major problem occurred in this case? So, major problem encountered with any measuring instrument is there. The error means the difference between actual value and measured value. So there is therefore it is necessary to select the appropriate measuring instrument and measuring method for which it minimizes the error. So to avoid these errors in any experimental work, careful planning, execution, and evaluation of the experiments are essential. Now, how to select the particular instrument for the measurement of particular quantity? So, for the selection of the instrument, the knowledge of performance of characteristic of instruments are very much essential. There are two different types of characteristics. The first one is a static characteristic, and the second one is dynamic. So we are going to discuss about the static characteristic of that instrument for the selection of instrument for measuring the particular physical quantity. The first one is the instrument. That is the device or mechanism used to determine or to measure the present value of that quantity under that measurement. For example, if we want to measure the diameter of a ball bearing, so for that measurement, not required scale, with the help of vernier caliper or micrometer screw gauge, we can measure that quantity with greater accuracy. So instrument that is actually used to determine the present value of that quantity under that measurement. Second one is the measurement. What is that measurement? Measurement is a process of determining the amount or degree of accuracy by comparison with the accepted standard of the system units being used. Means in short, we can say that there is a comparison of unknown quantity with the known standard. That process is called the measurement. What is about accuracy? Accuracy is the degree of exactness, that is a closeness of a measurement compared to the expected value. Suppose there is some desired value, and when we measure the particular quantity and when we reach towards that desired value, then we can say that we are very accurate. Means degree of closeness or exactness in that measurement, which decides the accuracy of that measurement, also accuracy of that instrument. Then now what is about resolution? There is the smallest change in a measured variable to which an instrument will be respond. So how much small variation in which our instrument gives the information about the measurement of that quantity. So it gives the information about that resolution of property of that instrument. Then next one is the precision. Precision, a measure of a consistency or repeatability of a measurement. That is, a successive reading does not differ. When we perform the experiment, suppose when we find the length of any object, so not necessary to take only one time. If we perform the experiment for number of times, so for that measurement, it does not give any difference. Then we can say that this is a precise. So precision is a consistency of the instrument output for a given value of input. If the length of the particular quantity is 10 centimeter, with the help of a scale, it gives 10 near about 10 centimeter, close to that to 10 centimeter number of times without any too much difference. Then we can say that the readings are precise. Expected value, the design value, that is the most probable value that calculation indicates one should be expect to measure. So that value is called as the expected value, or also called as the desired value. What is meant by error? Error is the deviation of true value from the desired value. That is a measured value from the desired value. So when we say the difference between these two values can be said that the error of that measurement. And finally, sensitivity. Sensitivity is the ratio of a change in output of that instrument to the change in input or measured variable. So that ratio is called as the sensitivity. If all the properties are observed in that instrument, then it gives the correct reading for that particular measurement value of that particular unknown quantity. So while measuring the particular physical quantity, minimum all these characteristics should have available in that instrument. Now we'll see the errors in measurement. So what about errors in measurement? The degree to which the measurement near to that expected value expressed in terms of error. That is a actually there is a difference between actual value and measured value. They are expressed in terms of either absolute error or percentage error. Absolute error may be defined as the difference between expected value and measured value, and whose equation is equal to yn minus xn. So yn is expected value and xn is a measured value, and the difference is the absolute error. It is denoted by small e. The percent and the error can also expressed in terms of percentage. Absolute error divided by expressed expected value into 100. So that value is yn minus xn upon yn into 100. But this error is not expressed only in terms of error. It is expressed in terms of accuracy rather than error. So relative error A is equal to 1 minus that mod value. And in percentage of accuracy, A is equal to A into 100. So in this way, we can